So we'll do a reminder problem, and how teachers build these problems up will probably help you understand how to then unravel it. Typically we'll go, okay, we have some function y. Let me back that up and make a thinner thing here. Will equal two factors. X, how about -6? And how about x plus 3? And this is actually going to be your end goal. You're going to see what I'm going to do as a teacher to turn this into a problem. I'm going to FOIL. FOIL was that acronym meaning multiply everything in this first term by everything in the second term. So basically first times first time, or your outsides, your insides, your last, whatever. That acronym's kind of cheesy anyway. X times x is x squared. X times 3. -6 times x. -6x, and then -6 plus 3.
-3.
That's -6 plus 3. Mm-hmm. What's -6 times 3?
Oh, times. I don't know.
Well, what is 6 times 3?
18?
Yeah, 18. So what's -6 times 3?
-18.
-18, okay. The next thing I'll do here is I'll combine like terms. So anything that has an x squared in it, and we only have one of them, okay. Anything that has an x in it, so now we get to do 3x minus 6x. So you're up 3 x's, and then you lose 6 of them. Now how many do you have?
3.
You have 3. Do you have a positive, a -3x, okay. And then anything that's just a whole number, just the -18. So now I do this, I go, that's not your problem. And I kind of gave you a bunch of hints on where to go from here. But you can pick whatever color you want, and you're basically going to unravel the work I just did to ravel up. And I'll have you scoot in just a touch. The microphone, yeah, we're good.
Okay. Jeez. I'm not sure how to do this.
It might help to start with that initial structure, being the 2 sets of parentheses that are multiplied by each other. Nice, and that y should be equal to those 2 sets of parentheses. Exactly.
So, x.
Mm-hmm.
And then -3x and -18. And you times it, right?
So if you times them, you would ideally get back to this original problem, because this is like this is the factored version, and then this is the multiplied version or the expanded version. So you should be able to go back and forth between these two. That's fine. This is fresh, and it's been 2 weeks. So if we did times them, for example, if we did x times x, what would we end up? That'd be awesome, right? And then what about x times -18?
-18x.
-18x. So we're already kind of below here. Maybe if this was +15x, but what's -3x times x?
-3x squared.
Yeah, -3x squared. So now we're starting to kind of mix the terms in this problem with the terms here. But as a reminder, the 2 terms that are going to go in these end spots are going to be 2 numbers that multiply to -18. And then those same 2 numbers are going to add to -3. So if you remember, just as a visual reminder, this is kind of what you did last time. You found 2 numbers that multiplied to 28, but then you had to make sure that those numbers also added to 11. And that's why you picked 4 and 7. Okay, so you can go back and kind of make that same factor tree if you want.
So the -18?
You're trying to make -18, exactly. Right. And you can just worry about the positive, or you can just worry about the numbers and then the negatives and positives after.
would it be -6 or -3? -6.
Yeah, there you go, right? And why did you just make that decision?
Because they add to this. And then...
Cool. Well, you've made the right decision here.
Mhm.
It'll probably help you if you double tap that pencil. And then you're the small eraser, so erase that term. And then erase that term. And then even your pluses and minuses, because you might not have those quite yet. Now double tap to go back to your pen. These are the numbers that are going to go into those two spots. Okay. We're not going to write this all out, but let's just check ourselves quickly. X times x?
X squared.
X squared. -6 times 3?
-3. Or -18.
-18. Now, 3x minus 6x. I did kind of...
-3.
I did those 2 and 1. See it, but that always works out because you're always going to end up with some amount of x's and then a different amount of x's. You're going to add them together, and that's why those two numbers are going to add to the middle number. Okay.
So, do I multiply now?
So you've got your factored form. Now I'm going to ask you, let me write a word down here to see if it springs your memory. This is what I'm asking you to find. Essentially where y equals 0. They're called the zeros or the solutions, and we'll see it on a graph again. But your goal is to find some x value that you can plug in. There'll actually be 2 of them. That when you do plug that value in, the whole equation equals 0.
So, -3.
-3 would be one of them.
And 6.
+6 is another, right? So typically you could write, like maybe in this corner, x equals -3. And then like x equals +6. Cool. Put a box around it because you deserve it. Nice, you got the perfect box. And then really quick, just to see it, so we have x squared minus 3x minus 18. Let's just go ahead and try that. So x squared, and then it was minus 3x minus 18. And where do we cross?
-3 and 6.
There we go, right? Okay, so you solved it algebraically, but graphically you can find the same answers actually quicker. And in fact, you don't even have to find the zeros with the graph. You could find the ones, which are like -3.1 and 6.1. You could find the fours, which is like -3.5. Those aren't really as useful, but you can find the x value at any y value you want. That's the power of a graph. This is like every answer you could ever want in one picture.